Welcome to a new video which is about L'Hopital's or L'Hospital's rule. After I show you when you can use L'Hopital's rule, I will solve instructive and challenging examples relevant to the topic. If this is your first time here and if you want to support this channel, don't forget to subscribe, click on the bell to turn on the notifications to be aware of the upcoming videos. We have a lot to cover, so let's get started. Okay, here guys, we have a definition about where we can use the L'Hopital's rule. By the way, I will prefer saying L'Hopital's rule comparing to L'Hospital's rule in this video. If you look at the first row here, it says when limit of f of x divided by g of x. So we have a fraction here, okay? Limit, I didn't put here when x goes to somewhere, okay? I just put it here. We might have a case where when x goes to a constant number, or we might have a case where x goes to positive or negative infinity. So in both cases, we have a fraction f of x divided by g of x. If the result of that fraction is equal to 0 divided by 0, what I mean by saying result is the limit of that fraction, okay, or the infinity divided by infinity, then we can apply the L'Hopital's rule. How? Well, we just take the derivative of the numerator and divide it by the derivative of the denominator, okay, and then take the limit. So this is equal to the original case, and we have a note here, and it says after applying the first derivative, okay, if the value of the limit is still 0 divided by 0 or infinity divided by infinity, then we can apply the second derivative to the numerators and denominators again, okay. And at the end of second derivative also, if we get 0 divided by 0 or infinity divided by infinity, and then we can apply the third derivative and so on. And we have an example here, and it says when x goes to infinity, what is the value of 6x minus 5 divided by 3x plus 2? Of course, before continuing, I should say that you should know the derivative, okay, in order to solve these questions. So if you put infinity instead of x in the numerator, okay, we're going to have infinity in the numerator divided by, if you put also infinity in the denominator, we're going to have also infinity in the denominator. So what we're going to do is, we can take the derivative of the numerator. If you take the derivative of 6x minus 5, then we're going to have 6, of course. And if you take the derivative of 3x plus 2, derivative of this, and we're going to have 3 from here. So we will have limit when x goes to infinity. This is going to be 6 divided by 3, which is going to be 2, guys. But there is also another way to solve this question, and that is, you can solve this question actually without applying the L'Hopital's rule. How? Well, if you remember, in one of our previous videos, I said that if x goes to infinity, okay, if there's a fraction like we have here, and then look at the highest powers, okay, the highest degree is x and its coefficient is 6. The highest degree is x in the denominator as well, and the coefficient of it is 3. So because the degrees are same, just divide 6 by 3 and that is going to be 2 as well. So as you can see, if you prefer to solve this question in the second way that I just said, that's going to be shorter than the way of L'Hopital's rule. So sometimes the L'Hopital's rule may take some longer time. So it depends on the question, of course. I just want to say you that you should take this point into account as well. And let's continue with the next question. And in this question, guys, if you put 0 instead of x, we're going to have 0 minus sine 0 is going to be 0 divided by 0 to the power of 3 is also 0. So 0 minus 0 is going to be 0. We have a case where the fraction is 0 divided by 0. The limit of the fraction is 0 divided by 0. So in that case, we can apply the L'Hopital's rule. And if you take the derivative of the numerator, let's say x minus sine of x, and the derivative of this is going to be, guys, 1 minus the derivative of sine is going to be cosine, okay, cosine of x, and the derivative of x cubed. If you take its derivative, then we're going to have 3x squared, guys. So the question is going to be limit when x goes to 0, guys. I'm going to have 1 minus cosine x divided by 3x to the power of 2, guys. And if you put 0 right now instead of x, then we're going to have cosine 0 is going to be 1. So I'm going to have 1 minus 1 divided by 0, which is going to be 0 divided by 0. So as you can see, still I have an undefined condition, which is 0 divided by 0. And then I am allowed to take one more derivative in this case, as you can see. So If you take the derivative of numerator and denominator one more time, then we're going to have limit when x goes to 0. The derivative of 1 minus cosine of x is going to be, the derivative of cosine is negative sine. So there is also negative in front of it. So we're going to have plus sine. But the derivative of 1 is going to be 0. So we're going to have sine x, guys. And if you take the derivative of denominator one more time, then we're going to have 6x. And now if you put 0 instead of x, then we're going to have sine 0 still is going to be 0, and 6 times 0 is going to be still 0. As you can see, after the second derivative, still we have the undefined condition, 0 divided by 0. That means we can apply the L'Hopital's rule one more time, which is going to be the third time actually. And once you do it, we're going to have limit when x goes to 0. The derivative of sine of x is going to be cosine of x, guys. And derivative of 6x is going to be 6. And now if you put 0 instead of x, cosine 0 is going to be 1. 1 divided by 6. And as you can see, we have a number. And there is no any variable as x. So that means we got the answer that we are looking for. And the answer is 1 divided by 6, guys. And let's continue with the next question. And we have a new question, and it says limit when x goes to infinity, what is the value of e to the power of x divided by x squared? And if you put infinity instead of x, then we're going to have e to the power of infinity, which is going to be infinity, guys, divided by infinity squared, which is going to be still infinity. So we have an undefined condition, and then we can apply the L'Hopital's rule in this case. And if you take the derivative of e to the power of x, we're going to have still e to the power of x. So the question is going to be when x goes to infinity, guys, e to the power of x divided by the derivative of x squared, which is going to be 2x. And if you put infinity now instead of x, then still we're going to have infinity divided by infinity, guys. And that means I can apply one more time the L'Hopital's rule, and once we do it, we're going to have limit when x goes to infinity. And again, if you take the derivative of e to the power of x, still it's going to be e to the power of x divided by the derivative of 2x is going to be 2, guys. And now if you put infinity instead of x, we're going to have infinity divided by 2, which is going to be infinity, guys. And in this case, the answer is going to be infinity. And let's continue with the next question. Again, when x goes to 0, what is the limit of this fraction? If you put 0 instead of x, then we're going to have 0 plus 1, which is 1, 1 minus 1, which is 0, 0 divided by 0, which is an undefined condition. That means we can apply the L'Hopital's rule. So once you apply the L'Hopital's rule, we need to know how to take the derivative of a square root, by the way. So let's say we have the square root of x plus 1. How we can take the derivative of this? Let me write it one more time. This is going to be equal to x plus 1 to the power of 1 divided by 2, right? And we are trying to take the derivative of this. And how we can take the derivative of this? Well, this 1 divided by 2 is going to come up front times x plus 1 to the power of, and decrease 1, subtract 1 from the power, so it's going to be negative 1 divided by 2, guys, times the derivative of the inside, which is x plus 1. The derivative of x plus 1 is 1. So that is going to be equal to, guys, 1 divided by 2 times, because of this negative, we're going to have 1 divided by, let me write it here, 1 divided by square root of x plus 1, guys. The derivative of square root of x plus 1 is going to be finally 1 divided by 2 times square root of x plus 1, guys. And now, if you take the derivative of the numerator here, then we're going to have the derivative of negative 1 is going to be 0. So it's going to be 1. Okay, let me write the limit part as well. Limit when x goes to 0. And we have 1 divided by 2 square root of x plus 1, guys. And the derivative of x is going to be 1, guys. And now if you put 0 instead of x, we're going to have 1 divided by square root of 0 plus 1 is going to be 1. 1 comes out as 1, but there is also 2 in the denominator. So it's going to be 1 divided by 2 divided by 1. So the final answer is going to be 1 divided by 2, guys. And as you can see, it took just a little time to calculate the derivative of the square root of x plus 1 in this case. Well, is there any other way to solve this question? Actually, there is another way to solve this question. Like you can multiply the fraction by the conjugate of the numerator. So once we do it, let's say, let me write the question again. If I multiply both numerator and denominator by the conjugate of the numerator, then we're going to have square root of x plus 1 divided by square root of x plus 1 plus 1. Okay, as I solved many times in my previous videos, if you think this is a and this is b, so from the first term we're going to have a minus b. From the second term we're going to have a plus b, guys. So that means there is a formula. Let me write the formula on the left up corner. So a minus b times a plus b, and that is, guys, a square minus b square. So this is gonna be equal to, guys, limit when x goes to 0, the square of square root of x plus 1, which is x plus 1, guys, minus the square of 1, which is 1, divided by x times, we can just multiply this by x. So in the denominator we're going to have in the parentheses square root of x plus 1 as well. And as you can see, this one goes with this one. What we can do is we can just simplify this x with this x. So in the numerator we're going to have 1 divided by, if you put 0 instead of x, then we're going to have square root of 0 plus 1, which is 1. 1 comes out as 1. 1 plus 1, which is 2. So as you can see, still you're going to get 1 divided by 2 as a solution. What I'm trying to say is, let's say you don't know how to take the derivative of square root of x plus 1. So you can try to find another way to solve this question as well. And let's continue with the next question. And this is our last question, guys, in this video. And in the question it says, when x goes to infinity, what is the value of ln x divided by 2 times square root of x? And again, if you put infinity instead of x, then we're going to have ln infinity, which is infinity, guys, divided by, again, we have another infinity in the denominator. That means we have an undefined condition, so we can apply the L'Hopital's rule. And once we take the derivative of ln x, limit when x goes to infinity, the derivative of ln x is going to be 1 divided by x, guys. And the derivative of 2 times square root of x, as I showed you in the previous example, the derivative of square root of x is going to be 1 divided by, okay, let me write it, 2 times 1 divided by 2 square root of x, guys. Those terms will be gone. And let me continue upright. So limit when x goes to infinity, guys. We're going to have 1 divided by x times square root of x divided by 1, guys. And that is going to be limit when x goes to infinity, square root of x divided by x can be written as square root of x times square root of x. These will be gone. So we're going to have limit when x goes to infinity, 1 divided by square root of x. And now, if you put infinity instead of x, then we're going to have 1 divided by infinity, which is going to be 0, guys. So I can increase the number of questions, but I think you get the idea how we can solve such questions. If you have any question, you can put them in the comment section below. Thank you for watching, and hopefully see you in the next video.